Okay, well, let's just draw some graphs for fun here. Here we have our plot of r equals 6 times sine theta, as we saw before. And if we change that 6 to, say, a 4, the center of this circle should change, but the general shape of the graph is the same. It's a circle with the center on the y-axis at a distance of 2 from the origin, and its radius, the radius of the circle is 2. And likewise, if we graph the equation r equals 8 times cosine theta, as predicted, it traces out a circle, but this time it's in the right half of the plane, and the center is on the x-axis at the point x equals 8 over 2, and this also gives us a circle. Now we had our cardioid in class, r equals 1 plus cosine theta, and it's this heart-shaped graph, and as theta swings around from 0 to pi, the value of r gradually decreases from 2 to 0, and then as it swings around from pi to 2 pi, the value of r increases again. Now if I change this just a little bit, say I take 1 plus 1/2 cosine of theta, and if I graph that, then things change just a little. It's a mildly heart-shaped object, but you see it doesn't come into the origin here at 0. I could also change that constant. I could graph 1/2 plus cosine of theta, and we see that this also changes the graph. As the angle swings around from 2 pi over 3 to pi, the r values are actually negative, and so we have this inner loop in our heart-shaped object. And the same thing is happening from pi to 4 pi over 3, and we get back to our heart-shaped design from 4 pi over 3 to 2 pi. So this is a heart with a loop in it, and these are variations of the cardioid graph. Now what happens if I want to graph the equation r equals cosine 4 theta? Well, something very interesting happens here. As theta increases from 0 to pi over 2, we're looking at the cosine of angles from 0 to 2 pi. And as we run around from 0 to pi over 2, we get something like a petal of a flower plus 2 half petals. The same trend continues as theta increases from pi over 2 to pi. So it looks like we're getting the petals of a flower here, and the same thing happens as theta increases from pi to 3 pi over 2, and likewise as theta increases from 3 pi over 2 to 2 pi. And of course this is periodic in theta, so now we have the complete graph of this equation, and it looks like a flower with 8 petals. So whenever you're graphing r equals cosine 4 theta, or even r equals sine 4 theta, you're going to get this flower with 8 petals. Now, if we change to cosine 3 theta, then the graph looks a little different. So remember, the graph of r equals cosine 4 theta had 8 petals, but the graph of r equals cosine 3 theta has some periodicity here, and it only has 3 petals. So the graph of r equals cosine n theta when n is odd only has n petals, whereas the graph of r equals cosine n theta where n is even has 2n petals. And we can do the same thing with sine theta. Here we have the graph of r equals sine 8 theta, and we get a flower with 16 petals. And if I were to take the graph of sine 9 theta, of r equals sine 9 theta, I should get a flower with 9 petals. And this is indeed the case. Here I have the graph of 1/2 plus sine 3 theta. So r equals 1/2 plus sine 3 theta. And let's see what kind of graph that traces out. Well, you see as r swings around, the r values flip from positive to negative, and the negative r values give us some small petals at the center, and the positive r values give us 5 large petals on our flower. Here's another interesting graph. It's the graph of r equals theta, and you can imagine that as theta increases, r increases here. So as theta increases, the distance of the point, the corresponding point on the graph from the origin, increases, and we get this spiral. This graph does not repeat itself. It's this never-ending spiral coming out from the origin. Here's a graph related to a question on your homework. If we want to plot the graph of r equals 50 times cosine 2 theta, as r swings around from 0 to pi over 2, it traces out this four-leafed flower. And you see that for this graph, as theta swings around from pi over 4 to 3 pi over 4, the r values in the graph are negative. And then they become positive again at 3 pi over 4, and negative again at 5 pi over 4, and then positive again at 7 pi over 4. And the actual graph you have to talk about on your homework is the graph of r equals the square root of 50 times cosine 2 theta. And you see that the square root of 50 times cosine 2 theta doesn't exist for values of theta between pi over 4 and 3 pi over 4, and this is because 50 times cosine 2 theta is negative in that interval. And so the graph picks up again when r is positive. Again, it disappears when the angle theta is between 5 pi over 4 and 7 pi over 4, because in this case r doesn't exist. We don't have the square root of a negative number, and this graph picks up again between 7 pi over 4 and 2 pi. So this graph gives us basically a graph of infinity.